Hi guys. So day 4 of the coronavirus break. I hope you're enjoying your vacation. It's been a rough morning. Okay, so I haven't had all my coffee yet. I just did this lesson with my kids and didn't end well. Like they struggled to follow directions and not like this isn't really school, so I got a couple eye rolls, which then resulted in, how I, don't deal well with that sort of disrespect. So thought I'd try this lesson again with just you and me, so you can understand it. It'll be a little quicker. So one thing that we figured out about these spring scales is if you can see here, you see the green ledge right there going up and down. Sometimes it doesn't start on 0. Do you see that? And so we had to use this white thing to adjust it. So lefty-loosey. So there it's starting, see, and even like these aren't the best scientific instruments. So that's a little too far down. And if I turn it this way, it's different too. So here I'm gonna adjust it like that, and then I'll tip it on its side, and good enough. Okay, so I have it set to 0 now. So it'll be a little bit more accurate. So today we're gonna be looking at pulling loads. Yesterday we talked about force. So when you push an object, you're exerting a force on it. And so I'm exerting a force on this. But it is an interaction between two objects. If this object wasn't here, no force. Since this object is here, there is a force. So a force is an interaction between two objects. And so we can use that. So we're going to take a look at notebook sheet 1 and 2. So I have that uploaded in the Google Classroom. It's a PDF. If you have trouble accessing a PDF on your device, just let me know and I'll send you a different format of it. I can convert it to like Google Docs, so I can just take a picture and send a JPEG. That would be fine. So 1 and 2 look like this, pushes and pulls. Okay, and so the directions here say, part 1, pushing and pulling different masses. You will need 1 spring scale, 3 loads, a rubber band, and a plastic mat. Use a rubber band to bind 3 loads together before pulling them. So here I have the black mat, and these are the loads. So they're just little cubes, and they're pretty hefty. I mean, this would hurt if you chuck this at somebody. And so I've got 1, I've got 3 of them, and that's what we'll be dealing with. And so question number 1, I'm going to grab my rubber band too. Question number 1 asks, how much force in newtons does it take to push these masses? So we will be pushing, and I will be watching the green here move. And so we'll be able to see how much force I'm exerting in newtons. So the picture shows 1 load. So I'll remove this. And the black mat is just to reduce any other forces like friction. So I'll set this here, and I will push it here. You got to push nice and slow because it kind of jumps. And if I'm pushing here, it's like 0.7 newtons. It tends to stay there. So in trial 1, I'm going to write 0.7. I'll do a second trial. Be watching this. That was more 0.8. See how slow I'm going? So 0.8 newtons, and then trial 3. back to 0.7. Okay, then to calculate an average, I add those three together. So I'm going to do 0.7 plus 0.8 plus 0, whoops, plus 0.7. It gets me 2.2, and then I divide that by 3, and it's 0.73. So I'll go out to the 100th place, 0.73 newtons. All right, now it asks me to do 3 loads, so I need to rubber band these together. So I got that, and I'm going to do the same process here, and okay, so pushing that. Oh, a lot of jumping. It tends to even out right at 2 newtons. Second go around. Little jump in there. Still right at 2. And then trial 3. Still at 2. All right, so that would be really easy to calculate the average. It's going to be 2 newtons. All right, so the next question asks, predict the force required to push 2 loads. So instead of 3, we're going to take it down to 2, and we're going to push it, and I'll make my prediction first. So we need to find like the number in between, I think. So what I do is I'm going to do maybe like 2 newtons minus 0.73, and it's saying 1.27. So what I did is I took the 3 loads, subtracted the 1 load, so took that off, and I'm predicting that it's going to be 1.27 or around 1.3. Okay, so I'm going to write that down. I'm going to write 1.3 here, and now I'm going to test it. All right, make sure we're still at 0. Okay. No lie, 1.3 is right, so spot on. All right, so now it asks us, question number 2 is how much force in newtons does it take to pull these masses? So I'm going to take my load and I'm going to tip it on its side, and then I'm going to use the hook here. And so if I'm doing this, when I pull, it's going to drag it this way and it'll pull. And so I'll still be watching the green ledge there. So do this and flip that around here, and I'll hook it there, and then I will pull. I got 0.6 newtons. So we'll do trial 2. That's pretty steady at 0.7. Okay, and then trial 3. .7 again. We'll do the average here. Again, this is in newtons. So to get the average, I'm going to do 0.6 plus 0.7 plus 0.7. And that equals 2 divided by 3. And I get 0.6 repeating. So we're going to bump that up to 0.7 will be our average. Okay, and then 3 loads. So I'm going to attach my loads here. Okay, and back it up, and I'll watch here. All right, so we're at 2. So 2 newtons. Bring it back, hook it up. Second trial, 2 newtons again. And then third trial, got 2 newtons again. All right, so the average here is pretty easy. 2 plus 2 plus 2 divided by 2 gives us 2. Now, we got to predict the force required to pull 2 loads. So I'm going to use the same strategy. I'm going to take my 0.7 newtons and subtract that from 2 newtons. So, oh, I shouldn't need a calculator for this, huh? That'd be 1.3 newtons. Okay, and so my prediction is 1.3 newtons. Kind of going in between, so let's see what happens. Oh, the rubber band. It's stuck on the rubber band. All right, so move that down. 1.3. Yeah. Go me. Okay. So 1.3 newtons, and this says, what is the relationship between the mass of an object? So like the mass of this object versus the mass of this object, and the force needed to slide it across the surface. So if I have 2 loads versus 1 load, what is the relationship between the mass of an object and the force needed to slide it across the surface? So I'm going to ask you to answer that question in the comments. You can make a graph out of that. So a graph, we're talking the L. Hang on, I'm going to get an Expo marker. So we're doing one of these. Independent variable goes down here. Dependent variable goes up here. So think about which one is which. Is it the mass or the force that's the independent and dependent variable? And then it's probably, it'll either be a positive relationship or a negative relationship. So why don't you do the graph and then tell me in the comments along with your answer, what is the relationship between the mass of an object and the force needed to slide it across the surface, whether that is a positive relationship or a negative relationship. Remember, positive goes up like that, and negative goes down like this, and this is a fancy term for that is an inverse relationship. Yay, review in math and stuff. In addition to that, see if you can get your homemade spring scale to pull loads and see if you can figure out how to calculate the force. So I'd go back to that website. It kind of gives you some formulas. You're going to need a ruler and a scale. So my house scale looks like this. Just a little food scale, so you can put your portions here and measure it. It measures it in grams, which is fine. So you can kind of say, well, if it stretches this much, it's this many grams, and then you can use Google to convert that to newtons and see what it is. If you're up for this challenge and you have all the materials, cool. Another challenge I'd like you to try is convert your spring scale to be able to use a push force. So in here, we've got the spring in a cylinder. Is there something you can do to your spring to help you push loads as well as pull loads? right, so that's your challenge for today. I'll make a new document so you can upload pictures of your builds. And I look forward to reading your comments online. Miss you guys. Talk to you later. Bye.